Indian agriculture is built on a massive scale, yet it remains tethered to a single biological rhythm. Because 2/3 of the country's agricultural land is rain-fed, the food supply for over 1 billion people depends entirely on the arrival of the monsoon. That seasonal predictability is now fracturing. In the rain-fed belts, moisture stress is becoming chronic, as prolonged droughts bake the topsoil and threaten the survival of livestock. Simultaneously, the eastern part of the country is facing the opposite extreme. Erratic, hyper-intense rainfall events now trigger frequent floods that overwhelm rural infrastructure and drown standing crops in a matter of hours. This chart maps the projected impact of these shifts. Under a scenario where temperatures rise between 2.5 and 4.9 degrees Celsius, rice yields are expected to drop by up to 40%, while wheat yields could plummet by more than half. The disruption goes deeper than a few bad seasons. The increasing frequency of these extremes has effectively blinded traditional forecasting methods, leaving farmers without a reliable way to prepare for incoming climate shocks. These combined pressures indicate a shift toward permanent volatility. The foundational climatic constants that once guaranteed food security are being replaced by a system defined by its unpredictability. Rising temperatures hit the crop's internal biology immediately. Heat stress accelerates respiration and shortens the growth duration, forcing the plant to wither before the grain can fully develop. This thermal stress extends to primary water sources. The Himalayan glaciers, which feed India's most critical river basins, are steadily retreating due to rising temperatures. This creates a two-stage hydrological crisis. In the short term, melting ice increases runoff and flood frequency. In the long term, the river basins that sustain irrigation will face a massive, permanent decline in water availability. Along the coastlines, rising sea levels and intense cyclones force saltwater intrusion into the groundwater. This process contaminates the aquifers and renders previously fertile coastal soil unsuitable for conventional agriculture. The breakdown of the water cycle and soil degradation leave the agricultural landscape physically weakened, setting the stage for a second wave of biological threats. Livestock are equally vulnerable. High ambient temperatures trigger severe heat stress in dairy animals, reducing their ability to digest feed and lowering their reproductive performance and milk yields. In the soil, the chemistry begins to fail. Heat speeds mineralization, but increases gaseous losses through volatilization, meaning nitrogen escapes before the plant uses it. These conditions starve crops, but provide an ideal environment for pathogens, expanding pest habitats into previously cold regions. Pathogen transmission accelerates as host susceptibility increases. New migrant pests, like massive locust swarms, can now invade and decimate vulnerable agricultural zones with little warning. Global warming acts as a force multiplier for these biological enemies. It strips away the plant's natural defenses, while simultaneously accelerating the growth and range of the pests that destroy them. India is responding to these systemic threats by rewiring its agricultural infrastructure. A network of research institutions is now focused on building a multi-tiered defense against climate volatility. Scientists are breeding heat-tolerant crop varieties while promoting conservation agriculture. Practices like zero tillage allow farmers to sow wheat earlier, helping the crop mature and head before the onset of extreme pre-monsoon heat waves. On the ground, resource-conserving technologies are being used to maximize water efficiency. Laser land leveling provides a perfectly flat surface for planting, ensuring that irrigation water is distributed uniformly with minimal loss. There is also a major push for crop diversification, moving away from water-intensive puddled rice toward pulses and oilseeds reduces the pressure on groundwater and increases the overall resilience of the farming system. High-tech monitoring forms the next layer of protection. Using space-based observations and microclimate modeling, authorities can now provide farmers with precise, early warning weather forecasts and contingency plans via mobile networks. This strategy also incorporates traditional ecological knowledge. Tribal and hill farming practices, such as ancient terrace farming and rainwater harvesting, are being analyzed and scaled to provide viable, low-cost adaptation measures. Stability now depends on this synthesis, merging orbital satellite data with centuries of indigenous engineering. To secure the food supply, The agricultural system is being adapted to match the complexity and speed of the changing climate.